Hello. Good evening. I'm hoping that having had some quite intense learnings during today and yesterday, you guys are going to appreciate a little bit of something a little bit lighter. It's a use case for serverless, but we're going to talk about getting stuff on the telly. And everyone loves telly, right? And I work for Red Bee Media. We'll talk a little bit about that in a minute. And obviously, you know, this is hopefully going to be a fairly interactive presentation, which will give you an opportunity to spot your favourite TV shows, and I'll come to that as well. So my name is Paul Markham. I work for Red Bee Media. I've been working for Red Bee Media for quite a few years. Previous to that, I worked in the radio industry. I'm not going to talk too much about me because that's not that interesting. As I said, I'm going to give you an overview on Red Bee Media, which is going to get the corporate kind of slightly boring stuff out of the way, and we can get on to the fun. We'll talk about our challenge, what we built, the resilience in DR, which is perhaps the most challenging bit of doing stuff for television, because when you turn on your TV, it always works, right? And that doesn't happen by accident. That there's an enormous amount of effort into making sure that that does happen, and we'll cover a little bit of that. And then finally, a bit of what do we learn? So there's some definite learnings that we got out of this, and we built this solution originally a couple of years ago. So there'll be some things that hopefully are obvious that you'll go, hey, why did you do that? And I'll fess up to saying we made some mistakes. So let's talk about Red Bee Media. At Red Bee Media, we do logistics for broadcasters and people who do video. By logistics, what I'm talking about is processing of media, video files. We do subtitles. We do audio description. Captioning subtitles is called in some parts of the world. We do playout of linear and OTT channels. What's playout? Playout is basically turning your TV schedule into a fully produced channel, which is then sent to a transmitter or cable or wherever, satellite, however it gets to you. And we do this all over the world. The client I'm going to talk about today, I can't tell you who this solution was built for commercial reasons, but the solution is, the broadcaster is on here somewhere, maybe in the middle because it's actually a UK broadcaster. I can tell you that much. So we work with some of the biggest names in TV, and if you watch TV any time in the last 10 years or so, you'll probably have consumed a bit of Red Bee Media's product. So let's talk about the thing, right? And I'm hoping you can spot some of your TV shows along the way. If you can spot what the TV show is that you see on the screen, on the slide, on the example, do shout it out, because this is the end of the day. We're trying to get a bit of energy in the room. And it's about the telly. And as I said, everyone loves telly. So, this is a true story. What's the show? Anyone? Fargo. So, like Fargo, I've taken a bit of liberty with the truth here. The names have been changed. I have simplified parts of this solution. It is not, I haven't included every tiny little detail of what we built, because that would be too complicated for a presentation this afternoon. So that's my disclaimer. What was the challenge? Show? Anyone? Crystal Maze. Thank you very much. You're getting the idea. Video files are big, and there's a lot of them. We have to, every time something gets on the telly, we have to get a final video file, sometimes audio description file, generally a subtitle file. It has to get to the main service, it has to get to the DR service, it has to all be there ready on schedule. And yeah, we've got 30 to 40 programs on a channel per day. Each broadcaster might have 6, 7, 10, sometimes more than that channels. You saw the number of broadcasters we work with, so we're talking about hundreds of files that have to be in the right place at the right time. And if they're particularly big, that might present a logistical challenge. It's a bit of a production line. Anyone name the show? Inside the Factory. Greg Wallace. Some people might view stuff that goes on telly is a bit like a toilet roll production line. It's just an opinion some people might have. I'm not advocating that at all. But it's a production line, right? We have to get all of these files, we have to stick them on a conveyor, we have to get them in the right place, we have to make sure that they're available so that when you turn on your telly, it's there. I mean, I think it's also worth pointing out that you don't want an I/O problem in the middle of a TV program. You don't want hundreds of thousands of people around the country to be sitting there watching the TV, screen freezes. So not only does it have to be in the right place at the right time, we have to obviously manage the I/O on the different servers that are playing out the video for the different things. It's not a TV show. Watching some channels can feel a bit like Groundhog Day, right? Because there's repeats, and some channels like repeats more than others. But repeats present us a challenge, which we'll see a bit more in a second. But repeats can happen same day, same week, same month, next year, 10 years' time. And normally with our workflow, we just say, it's on the schedule, we'll send it. If it's on the schedule again, we'll send it again. We also sometimes need to resend things to our servers for operational reasons. PLAYOUT, something crashed, something went wrong, send it all again. Yeah, because you just want to make sure it's there. And the reason that I'm talking about this will become clear quite shortly. So this is what our customer asked for. And one of the reasons that I can't tell you who the customer is obviously, this is one of those annoying customer requests, right? So we can't process media files that we already have. It's going to break our new system. So we want you to stop sending them again. So we're like, okay, well, you can probably do that. But then, here comes the killer line, unless we house kept them. Okay, so what, do you house keep them after a week, after a month? No. We just delete them when we run out of space. So how are we going to know? And this was an honest conversation. It's obviously been simplified, but this was a conversation in a meeting with the client. And so this last line came after a lot of head scratching. Well, maybe we could send you an inventory, a list of stuff that we've got. And you know, we're not going to delete stuff that is actively going to be on the telly today or tomorrow or even in a couple of days' time. So you can rely on that. But we'll send you a list of everything we've got. So just to kind of summarise where we are, our normal workflow, and bear in mind, we do this for all of those clients all around the world. We take a schedule, we say, hey, when's the media available? So we have to wait for media to come from production houses and from other places and people to make subtitles and all of those things. And then we deliver it, right? So it's a very simple transactional piece. Once something appears on the schedule, we've got a bunch of stuff to deliver. It happens, end of story, next thing on the schedule. So nice, easy, makes that production line go very, very smoothly. What our client asked for was this. And so we've got now a cycle, which means that we have that big evil thing that we have to deal with, which is state. Because instead of that nice, simple transaction, we've now got this inventory. And every time we want to look at that schedule and decide what to go next, we have to keep going around the circle. And you know, when you have a solution or have a bunch of solutions, let's be honest about it, for all of those clients, you don't really want to do something different. So even though this was a pretty big client, we were kind of like, we don't really want to have to do something different for these guys. But obviously we did, because they're the client. The customer's always right, or always something that rhymes with right if you're in the business. So obviously we did something with serverless, because that's why I'm here, right? What's the show? Thank you. What did we build? A grand design? Well, you can be the judge of that. So I'm going to go through. I'm not going to show you the tech stack to start with. I'm just going to go through the steps of how we develop this serverless workflow. Plenty of shows coming up, by the way. So this is a more difficult one. Thank you very much. It's a raven with a scroll for anyone who can't quite see that. So the raven represents the inventory. We get the inventory every 6 hours. We can adjust that. We can talk to the customer. They'll send it to more often if we want. But I guess one of the benefits of this, one of the nicer things about this problem, if you like, was that it wasn't it's not a real-time thing. We have 2 or 3 days maybe to get the right files in the right place to understand what we need. It doesn't come down to the wire in terms of, minutes or half hours. So we can deal with that every 6 hours. We receive the inventory, we stick it in an S3 bucket. The S3 bucket triggers the Lambda script, and the Lambda script basically dumps the DynamoDB table and replaces it with a new inventory. So what we're doing there is we're using our inventory as a state reset. We're kind of saying, right, when we get new inventory, we're going to say that's the state we're at, which helps us with the resilience and whatnot that I'll come to later. Step 2, special agents. Show. Thank you. Special agents, we have, obviously, the schedules are all, as you might imagine, legacy platforms. So we had to come up with a way of integrating with those. So we deployed these agents in Golang, and we could, one of the advantages of using Golang was we could take a legacy server. In the schedule case, it was a Windows server. We didn't have to worry about dependencies and versions of Java and all that other nasty stuff that you have to deal with, lots of testing and long lead times for legacy systems. We were just able to say, hey, here's a Golang executable, we'll stick it on this server, and it sends the scheduled items that are available. So don't forget, all of those different files coming in from production houses, people making subtitles, all of those things, we have a scheduled item, a scheduled list, and the agent sends that to the S3 bucket, to a different S3 bucket from the first one, right? It's not a show. We don't have to talk about him. File arrival triggers Lambda. And the Lambda of the schedule of stuff that we've got that arrives in S3 compares what is in the DynamoDB. And what's in the DynamoDB is what came from the inventory. So we're comparing what's there, and we're creating the delta, if you like, of that thing. So we get a list of items that were on the schedule but not on the inventory, so the stuff that needs to get to where it needs to get to, and we stick it in SQS. Nice and simple. And then the final step, show. Breaking Bad, brilliant show. Delivery agents. So the delivery agents run on our main storage servers, and they process items from that SQS queue. And each item is then sent via, again, it's a legacy delivery method. It all happens behind the walls of the network, and we'll talk a little bit about that in a second as well. And again, another Golang. Again, this wasn't a Windows server. This was another server storage front ends. They're plural, by the way, because of the resilience and DR, which we'll come to. So what we ended up with was this. So, it's nice and simple, isn't it? Inventory comes in, refreshes the DynamoDB, schedule, compare delivery. So, that's not rocket science, is it? Except, of course, we've got resilience and DR. Show. Fabulous. So what's the big challenge with resilience and DR is it's the split brain, right? No one wants a split brain. And if you remember, the client's requirement was they only ever want to get anything once. It's a little bit more complicated than that, because the client has 2 sites. And when they said once, they want it once at both sites. So they want it once at one site, once at the other. But what we needed to do was come up with something that would survive the loss of one of those sites. So the worst case DR planning is that there's a fire, there's something worse than that goes on at one of the client's PLAYOUT sites, and we can no longer, they can no longer use that, but we still need to be getting this content to the other side, right to the right place. So here is how we solved that challenge. So let's start with the inventory. So I said the inventory comes in every 6 hours. It's a clock, right? We get it every 12 hours from A, every 12 hours from B. So it comes in every 6 hours, but we're alternating between those 2 sites. By the way, before somebody asks, yes, the client sites talk to each other on the client side. They're synced up. So the inventory is, in theory, if everything's working at their side, the inventory is the same, or it would be the same generated by either side. On the other side, we've got our agents, our special agents. And again, we've got 2 sites, and those special agents are talking to 2 of those schedule servers. And we're doing that every half hour. So on the top of the hour, on the half hour. So don't forget, every time one of these comes in, that's when the comparison happens. And when the comparison happens, stuff gets added to the queue. When stuff gets added to the queue, it gets added back into the DynamoDB. So the state is being maintained there until the next inventory comes in a few hours later. And then when we come to the delivery, yes, we've got 2 sites. The client's got 2 sites. They both go to both. And obviously the beauty of the SQS bit is that that means that only one of our delivery agents is picking up the item to be delivered. And I should add as well, because some of you might have already figured this out, obviously if we've got 2 sites, we might have files that are not available on both sites. And so those delivery agents will look at the storage and say, oh yes, I've got that item, I can send it, or they will release that SQS message back into the queue so that the other agent can then come and pick it up and deliver it. So here we've solved our split brain, and the beauty of it is that we are relying on this serverless, Amazon serverless deployment in the middle to do the difficult bit of maintaining the state. And yeah, you know, Amazon don't promise 100% uptime on this stuff. Of course they don't, who would? But it's reliable enough for this requirement. And it's reliable enough that we can say, we know it's cross AZ and it's all of those things. So it's reliable enough that we can say, if we lose one of our sites or one of the customer's sites, and by the way, in terms of geographical location, there's a bit of overlap there because we operate on some of the customer's sites as well. Does everyone kind of get how that resilience works? So what we end up with is, with a bit more detail, is this picture. And I think one of the reasons that this was quite a successful solution is, if you go back and remember that what I said about this being an esoteric solution for us, right? Nobody wants to do something different for one client. And the great thing about this is that we're using the same schedule, the same storage, the same delivery mechanisms we're using for everyone else. We're just driving the metadata in slightly differently, and that all of the communication that's going on, and this keeps the security boys ultra happy, all the communication that's going on is all HTTPS. It all goes through our web proxy. And ultimately, all the stuff that's happening in AWS is not, it's not confidential stuff. So when you're processing next week's TV, right, your clients are a little bit nervous about, hey, what, you're putting stuff in the cloud? How secure is that? They're less nervous about that than they used to be. But fundamentally, one of our responsibilities is to make sure that next week's TV isn't available on the internet in places it shouldn't be. So the fact that all of this comms was HTTPS, the fact that actually all that happens up here is lists of material IDs which are meaningless to anyone who can't reference them back to the programs, and that there's nothing particularly sensitive going on. It's not particularly time critical. It needs to work from time to time. What do we learn? What's the show? Thank you. It's all right. We're nearly done with this. It's okay. I guess when people talk about serverless, they talk about cost. This is a monthly bill for this solution. We'll talk about DynamoDB in a minute. But obviously, this stuff over here, it's pennies, isn't it? And that's because we're not doing any scale. We're not scaling up. What we're leveraging is that resilience and that kind of that AZ out of the box that we get out of that serverless platform. All right, let's talk about DynamoDB. I think top right here, DynamoDB was just not the right choice. And you know what? We designed and built this solution literally weeks before Amazon turned around and said, hey, we're making you S3 Select. You can use S3 Select. And if only we'd waited. And how many people have had that experience? What else did we get wrong? I'll come to what we got right in a bit. What else did we get wrong? Inventory updating. Yeah, so obviously we quite naively thought when we send stuff to the client and the inventory that comes back soon after, that will all kind of happen quite quickly, right? Because don't forget, when we get that inventory in, it dumps the database, it resets it. So what started to happen was we'd get a schedule update and send a bunch of stuff that we'd obviously add to the DynamoDB, and then we'd get an inventory update that would dump all of that, but the inventory didn't include the stuff that we'd just sent, because there was obviously a bit of a time lag. Bottom one is, I think, maybe a more general learning that we thought, maybe quite arrogantly, we thought, hey, this is a pretty cool solution. It's just going to work, isn't it? Other people must have been there. And we thought, oh, well, it's quite simple, and if it breaks, well, we'll just go and figure it out. I think what we didn't appreciate was that the whole organisation wasn't quite ready for the serverless experience. It was, let's say it was a bit of a baptism of fire for some people, and I think we needed to do a lot more in terms of user interface, because even though this thing worked, other things that related to it didn't work very well, I guess like the inventory thing, and I think it would have been really useful at the start to have a basic user interface. And you know what, what's the reason we didn't build a user interface in the first place? Well, user interfaces can be a bit expensive, they take a lot of time, there's a lot of faffing around, and so we thought we could get away with it. We couldn't. And so even if it's something that shows the logs or something that just helps people understand that what's supposed to be happening is happening. What went well? Well, yeah, quick and cost effective. So we managed to deploy this solution. We got it built and deployed in a couple of months, which for broadcast, by the way, is unheard of. Deployed into production. So that was a big success. It's, yeah, as you saw from the graph, it's very cheap. Yeah, reliability's been good. Legacy integration. I mean, I think we're a bit wary of the agent approach. And I know it's not strictly serverless, but it's enabled us to use the serverless platform. The fact that we were able to drop these Golang agents onto legacy servers and actually not have to worry very much about them at all. They would have worked really well and didn't interfere with anything else that was going on. That was a great piece of learning. Yeah. So and you know, I know somebody's going to say, so have you fixed the DynamoDB? Why don't you go and replace it with S3 Select? I guess the very simple answer to that question is, you know, although that's a big chunk of pie, $327 a month, it's going to take a long time to pay that back if you're going to have to get a developer to spend a few weeks, even a couple of weeks, whipping it out. It's something we want to do, but it's one of those things that I think it's a bit of technical debt that doesn't cost that much in the big scheme of things, and then we kind of go, well, we kind of live with it, it works. I think as technical people, it offends us. It certainly offends me a little bit when I see that. I think we could make that go away, but in reality, it's probably more effort than it's worth at the moment. That much in the big scheme of things, I think we could make that go